Okay, in this first example, we have a high pressure receiver that has a liquid and vapor ammonia in it, and the temperature of the ammonia is 80 degrees, and we're asked to find the corresponding saturation pressure. Since there's coexisting liquid and vapor, we know conditions are saturated, so we can use our saturation table to find the pressure. I've chosen to use the Rita Caro exam packet, and I'm going to simply go to the ammonia saturation tables and look up our temperature, which is 80 degrees, and I see that the corresponding gauge pressure is 137.99 psig. So the temperature or the pressure corresponding 137.99 psig. Okay, in this second example, we have another vessel containing saturated ammonia, but it changed the temperature to 20 degrees Fahrenheit. So same situation as the last one, just a different temperature, and we're asked to find what's the density of the liquid ammonia. So I've kind of represented the liquid by underneath my wavy line, and vapor be on top. So what is the density of the liquid in these conditions? This time I'm going to use the ASHRAE Fundamentals textbook. I'm just using different books to show that there's various references out there that could be used to get the same answer. So I'm going to open to, in this case, chapter 30 in the ammonia table, R717. And along the first column, I'm going to find 20 degrees Fahrenheit. Then I'm going to move to the right to the third column, which is the density of liquid. And I find that it is 40.43. So the density of the liquid, which is typically the Greek letter rho, is what we typically use for density, 40.43, and the units for that are pounds per cubic foot. The truth is, engineers don't look at the saturation tables every day. Usually we're able to utilize tools like spreadsheets, maybe other software tools to get the information that we otherwise would be gained from a saturation table. But I always like to remind refrigeration professionals that just like a carpenter might use a nail gun 99% of the time, there's always those instances where you got to pull out the old hammer because of some situation. You want to make sure you know how to use that tool. It's kind of similar with the saturation tables. You don't use it every day because there's other tools available that are maybe more efficient, but you want to know how to use them when you need to. All right, in this third example, we have our same vessel. Temperature's changed again, so now it's 60 degrees Fahrenheit, and we're asked to find the specific volume of the vapor this time. So how much space does that vapor occupy? And I'm gonna use my third resource now. I'm gonna read book 1 just to show that the same information can be found from various sources. So I open to chapter 4, and I'm gonna do the same thing, which is find my temperature, which is in the far left column. I find 60 degrees, and now I'm gonna move to the right until I land at specific volume. Now, in the Rita book, it'll show specific volume of vapor and specific volume of liquid. Since we're looking for the specific volume of the vapor, I need to make sure I land on that column, which happens to be the 5th column when going from left to right. So the specific volume of the vapor is 2.7571. So little v equals 2.7571, and that units are cubic feet per pound. Okay. Now, if I were to have used the ASHRAE Fundamentals book in this case, if they would not have given me the specific volume of the vapor and the liquid. Instead, they'll only provide the density of the liquid and the specific volume of the vapor. But Rita gives specific volume and density for liquid and vapor. Why the difference? Well, you really don't need to have both, because specific volume is the reciprocal of density. So a reciprocal is a number divided by itself. And it just so happens that the reciprocal of specific volume is density, and vice versa. Let me show you. So 1 divided by the specific volume equals the density. We take this number here, 1 divided by 2.7571 cubic feet per pound. We punch that into our calculator. 1 divided by 2.7571. That equals 0.3627. Now the units are going to be pounds per cubic foot. And if what I said is accurate, that should correspond to the density of the vapor in the Rita book, which it absolutely does, because the density of vapor at 60 degrees is 0.3627. So I just demonstrated why you really don't need to be given specific volume and density in a table. ASHRAE Fundamentals doesn't do that. Rita does, makes it easy, so you don't have to do this reciprocal calculation when asked to find a certain value.